Hello, everybody, and thank you very much for coming to this session about continuous delivery with Jenkins and Gradle. My name is Alex Soto. I'm a software engineer at CloudBees, which is the company behind Jenkins. I'm an open source advocate. You can find me in several projects like Rockillion, ASCII Doctor, or Jenkins, of course. And yeah, you can follow me on Twitter. My tweet is AlexSotoB, and I think that it's the best way to approach me. If you have any question after the session or whatever, you can send me also an email or so, but Twitter is the fastest way. It's an intensive session, so if you have any question, please raise your hand and I'm going to try to answer it. Just when you have the question, don't wait until the end of the presentation. So software is everywhere. I mean that you can think about that in your mobile, your television, the tablets. I mean that every business in the software business. Even, for example, some companies are based on a traditional business are improving with software. You can think about like Uber or Airbnb or Just Eat, which are companies that using the traditional business, they are build their business around the software. But I like to show you some maybe funny examples. This is the first one. This is the cockpit of the A380. And notice that everywhere it's screens. I mean that there is no analog systems. And yeah, you can see that even there is a touchpad or a keyboard. So you can see that this plane has a lot of software. Another one is something that here in Spain we don't see it usually, which is that this is a Tesla car. And notice that all the HUD is software. And even sometimes when you start your car, you start the engine, you receive a message which says, there is a software update. Do you want to update it now or just wait until you can choose the date or so on? So it's quite strange that you can even install software on your car. This one is Windows 3.1 is still alive, and it just killed a French airport. And you will say, oh, okay, this is a news from 1999 or so. No, it's and this news, maybe you can see it, but it's from 2015. So 1 year ago, there was an airport in France that has Windows 3.1 installed, and when they migrate, or they installed a new package, all the system blows, and they stayed 1 day managing the airline traffic by hand. And the last one is 57 million slot machine win, blame on software error, casino won't pay. So even the slot machines has a lot of software inside, and maybe you can put your coin there and you say, hey, I'm rich, I've won $60 million, and oh no, this is a software error, sorry. So I don't know, this explains, and I think that at the end they didn't pay, but yeah, software is important in our lives. So we need to find ways to deliver software faster. Maybe because there is an error and we need to be able to fix it as soon as possible. Sooner, maybe we know that our competitors are going to throw to the market something similar, so we want to deliver it sooner than them. And of course, better, because if you have a lot of bugs, then your software looks pretty bad. So the way to do this is by using continuous delivery approach. And maybe you are wondering, what is continuous delivery? Some of people say, yeah, maybe it's a build tool, maybe it's a continuous integration server, maybe it's having automatic tests, automatic quality, automatic deployment. But yeah, probably you're right. All of them are true, but the most important thing of what continuous delivery is that it tries to deliver business value more frequently. And when we talk about business value, I'm not talking only about money. We are also talking about fast feedback. Maybe you want to deploy something, all your clients see, you get the feedback from your clients, and you decide, oh, yeah, they like it or not, so you can change it more quickly. So it's not only money, it's about the feedback of your users. And of course, if you want to deliver faster and sooner and better, you need to automate, because if you do all your process your manual tests, your deployment, your manually deploy or you manually build your software, then you probably are not going to deploy it so fast. This is something that probably most of you have seen once during your career, which is that the typical continuous delivery pipeline. Basically, when you want to do continuous delivery, you define your steps in several stages, and this conforms a pipeline like the car industry are doing. And basically, you have deployment, and then a developer deploys something, it commits this to your SCM, then you build, that software is built, then it runs a lot of tests here, and put commit tests, acceptance tests, but of course you will do like automated deploy tests, security tests, stress tests, and so on. After a lot of iterations, you will finally stage this something, your artifact something there waiting until someone decides if this artifact is going to in production or not. If you do this step of deploying to production automatically, then you are doing continuous deployment. But if what you're doing is, okay, I know all the test results, all the all the static analysis code, and everything is fine, then if there is someone who decides to deploy this on production or not, then you're doing continuous delivery. Finally, you decide to deploy this artifact or not. You decide to deploy, it goes to production, and then your clients can see the result, and you get feedback in terms of maybe money, or maybe feedback about if they like it or not, this new feature. But yeah, I've said that this is implementing continuous delivery with Gradle and Jenkins, so I don't want to spend more time with theory. There is a lot of books talking about continuous delivery, so and a lot of content. So the first stage of your continuous delivery pipeline we have seen is the commit stage. The commit stage is one part of the pipeline where where a developer develops something, they push this change to an SCM, then you compile the code, you run commit tests. Notice it's very important. I'm not saying here unit tests, I'm saying commit tests. We're going to see why. Then you run the code analysis to see or to try to detect some issues in your code. Then you assemble your application, and then you put this application or this artifact inside your artifact repository, waiting to be consumed by someone. Let's see how to implement this stage with Griddle. Basically, I suppose that everyone knows what is Griddle, but basically Griddle is a build tool writing as a groovy DSL. So the good thing of Griddle against other solutions is that you can put custom groovy code inside your build job, which is quite good. Let's see how to compile. In this case, Gradle has a file which is called build.gradle. And in this, if you want to create a war file, you do apply plugin war, and you're saying to the Gradle, hey, I want to load all the functions related to a war environments like webinf, or say take care of webinf and so on. Then I'm saying to all the projects that belongs to this project, with Maven you have modules. In Gradle you have a project, and then you can have sub-projects. You say all the projects and sub-projects are going to be compiled with version 1.8 of Java. It's going to have a group called org.starwars in this case, and the version is this version. And to pick up the artifacts, you're going to use the Maven Central repository. And finally, you can define the dependencies. You do it by using dependencies, and then you create a block where you put all the dependencies. In this case, I'm using provided compile, which is something very similar like provided a scope of Maven, that you're saying, okay, this jar is going to be used for compiling reasons, but not it's going to be packed inside the final artifact. And then you can call Gradle compile Java, and all your code is compiled. One thing that has been introduced in Gradle 2.12 is that compile only scope. Compile only scope, it's something like provided scope in Maven. Notice that here, in this example, since we are using a war, the war plugin contains the provided compile. But if you're using apply plugin Java, for example, for a Spring Boot project, then you cannot use provide compile, because provide compile is not provided by Java plugin. But since Gradle 2.12, you can use compile only, which is pretty similar like the scope in Maven. But of course, if you're using a Spring or Spring Boot, probably you know the BOM concept of Maven. BOM is bill of materials, which basically it fixes all the versions of all the artifacts that are in a similar group. Basically, it's like a master POM. And BOM files are not supported by Gradle by default. So you need to use a plugin. And in this case, you need to use the dependency management plugin, which to find a plugin is using the plugins, and then you do ID, and you put here all the ID of the plugin and the version, and it's automatically downloaded and install it for you. When you have done this, you can use this dependency management block, which basically says, what is the BOM file that I want to use? And you do dependency management import, and you put the Maven BOM. In this case, I'm putting all the BOM of the Spring platform. So when I add a dependency, like for example, compile dependency, notice that I'm putting org.spring-framework, Spring core, and I'm not setting the version, because the version comes from the BOM. So in this way, when I need to use Spring core, Spring or ARM, or etc., all these artifacts will belong to the same version. So you don't mix different components with different versions. Then we've seen that we need to execute tests. And to define test dependencies, you use test compile scope. And you define in dependencies block test compile JUnit, Hamcrest, for example. And in case you are going to use Mockito for mocking, you need to remember to exclude the group org Hamcrest, because Mockito comes with its own with Hamcrest 1.1, and since JUnit comes with Hamcrest 1.3, there is some class path problems. So you need to explicitly exclude Hamcrest from Mockito. And in Gradle, it's done by using exclude name. And one of the interesting parts where Gradle really shines in contrast of other solutions is that you can use test block. You can put test, you open the brackets, and then you can put there all the groovy code that you want. If, whiles, fors, whatever you want. And in this case, what I'm doing is, okay, I'm going to run a test, and my module has a system property, which is called Star Wars Planet URL, which is the URL where the application is deployed. It's inside my test. So what I'm doing here is say, okay, get the system properties and set Star Wars Planet URL with this string. And so here you can put an if, and you can say, if I'm in QA environment, the URL will be this one. Else, if it's in the stress test environment, the URL will be this other one, and so on. So it's groovy code. You can put whatever you want here. And to run it, you just run riddle tests, and this will execute the test. Notice that in this case, the tests that are going to be run is the ones that are in source test Java, the standard or the de facto location. And this is where you usually put all your unit tests. But as I've said, in the commit stage, there is not only unit tests. I've called commit tests. Why? Because unit test is not enough to know if you have break something or not. Usually, in the commit stage, what you want to do as a developer is be sure that you have not break anything. I mean that at least the application is going to start, and more or less its behavior is the expected one. So what you need to do is, in your commit test stage, put all your unit tests and choose some specific tests from integration tests, component tests, maybe if performance is important, stress tests, and so on. So what I usually do is I have a structure something like this, which I have integration test directory where I put all my integration tests there. Then I have a producer test where I put all my contract tests there. And then I have, for example, a stress test where I put all my stress tests there. And then, of course, I have the build.griddle and that it's a way to, it's a layout that you can use it. So you have your project, in fact, your microservice with your code, your unit test, and all the tests there inside. So you, with a quick view, any developer can see what you are testing and what not. And for include a module, it's really easy with Griddle. You only need to open or create a file called settings.griddle, which is put in the root of the project. And you do include, and you put the directory. And when you, with just this directory becomes Griddle subproject. I've seen, we have talked that basically you, in your commit test, you put your unit test and some chosen integration test, component test, and so on. To do this is really easy. You simply go to, for example, integration test/build.griddle, where you can put some specific parts of the build of the integration test. And I do, when you are executing the test phase, if the project has a property called happy path, then execute only this array of tests. In this case, I'm putting one test that is called Planet Service API test with the method should return the average. And notice that this is an array. It means that you can put several tests there. Even you can use regular expressions. So you could put Planet Service API test dot star, and it means that all the tests from Planet Service API test is going to be run. So how you set this happy path? It's really easy. You only when you want to, you're going to run integration test. You do riddle integration test. So it's saying I'm going to execute only the test from the integration test project, and -p, which is says I'm going to pass you a project property called happy path. So when these tests are executed, since the if will say okay, the property is there, then I'm going to filter all your tests, and I'm only going to execute the ones that matches these filters. So instead of creating several integration test projects, one for the full integration test and another like the small integration test project, you can choose here which test you want to execute in your commit stage and which not. Of course, then comes the code analysis part, which you can use PMD, jaco style, or find bugs, or your the tool that you like it more, and it's perfectly supported by Griddle. And after this part, you can let developers go. Basically, all these steps that I've mentioned now, it should take like 10 to 15 minutes, not more. So it means that you commit something, the developer stays there like 10 minutes. If everything's success, the developer can say, okay, I have not break anything. It seems that it's going to work. The application starts. The unit test pass. And probably if you are putting there some stress tests or key stress tests, you say, and my change has not impacted in the performance of the application, so I can go to the backlog and take another task or another job, and I can develop another thing. But of course, this is from the point of view of developers. But then what you need to do before assembling your application is run all the integration tests. And there are several ways to do this, or different also tools to do. And I recommend you using Arquillian, which basically what Arquillian does is it takes your WAR file, it starts the container that you have decided. For example, if you're using Tomcat, it starts a Tomcat. It deploys there your WAR file, it executes your tests, and then undeploy the WAR file and stop the server. And this is done in a JUnit fashion way. So it means that it's like you're writing a JUnit. And I mean that this is really interesting because you're running your integration test in an environment really near of what you're going to use in production. If in production you're going to use Tomcat, you're running your test on Tomcat. If in production you're going to use Yeti, you can use Yeti, Wildfly, or any application server or serverless containers can be used. And you're running your test in a real environment and not in some kind of a stubbed environment. Of course, you need to check the code coverage in this to say, okay, we have your new commit has not decreased the code coverage, and in this, I think that jaco is the de facto tool for checking the coverage. Basically, what you do is apply plugin jaco. So you're saying, I want to load jaco. You set the version of jaco you want to use. And remember that I've said that in your commit test, you're running unit tests, but also some integration tests or component tests and so on. So what you want to see is an aggregated coverage. You don't want to see, yeah, with unit tests you have reached 25% of coverage, in integration test 80% of coverage, and so on, because you want to have the aggregated data. To do this, what you need to do is define a task called, you can name it whatever you want, but it should be of type jaco report. You're saying, hey, when you want to create a jaco report, just check source sets, like source sets.main. This means that the sources are in the source sets.main. This is the source main Java directory. And check, take the root of, notice that I'm using build-dir. Build-dir is the root target directory. Check /jaco/test.exec. This is the file of jaco where it stores everything. Check this file. Then for each subproject is a variable that is there. You can use it. For each one, check if it has a test.exec file, because maybe in this project you have not run jaco. If you have run, add this exec file inside this array. So at the end, you have an array with all the exec files that you want to merge. And then what your only thing to do is say that the execution data is the files of this array. So what you're instructing jaco report is saying, build a report with all these files. And then you can configure if you want the output to be in XML or CSV, but you can put true or false, whatever you decided. And finally, what you can do is do a griddle, jaco root test report. This is the name of the task. And when you do this, you get an aggregated report with all the exec files merged and ready for you. So you don't need to check individually or merge it manually. This Gradle does this job for you automatically. One thing that is really important in continuous delivery is the versioning strategy. Keep in mind that in continuous delivery, we have said that you commit something, you run all the tests, then you run more tests and more tests and more tests. Yeah, it's always tests are really important. And at the end, someone decides if this artifact goes to production or not. So it means that if you arrive at almost at the end of the stage and someone decides that this thing should go to production, you cannot say, okay, I'm going to run again all the pipeline. So what you need to do is say, okay, then I deploy this artifact to production. So it means that every build is a potential release. So even or you can expect that maybe this is not going to go to production. You need to do exactly the same steps if you are going to deploy to production. This is very important. And the first thing is adding a version. Normally, you use 1.0 snapshot there, or 1.1 or whatever, and you said, okay, and now I need somehow to identify this release, because if it's going to go to production, I want to know which version goes to production. And one thing that you usually do is using the build number of your continuous integration system, which in the case, if you're using Jenkins, it's pretty easy. So what you are doing is renaming 1.0 snapshot to 1.0 and the build number, in this case, 134. To do this in Gradle, it's quite easy. Since in Gradle you have code, groovy code, what I usually do is creating a file called versioning.gradle that basically checks with a regular expression finds the version. In this case, I'm fine if it's 1.0 slash snapshot, what I am interested in in checking the 1.0 and then appended the build number. So this is the matcher, and I said, okay, find this, find in the version, find the major version and the minor version, and create a class called project version. This is a custom class that we're going to see now. This project version, which is my custom class, has a major number, a minor number, and the build number. And of course, you need to take care of implementing toString, because griddle, where it creates the artifact, it's going to call the toString method of that version. So what I'm doing here is saying project.version equal new project version. So I'm overriding the version variable to a new type. Project.version originally it's in a string, but then what I'm doing is like, okay, I'm going to override it to new project version with all the data, and notice that the build number is system.emp.source build number, where source build number is an environment variable set by Jenkins to get the build number. And then if you see the toString, you are saying that when I'm going to build the artifact, it's the number is the major dot the minor dot the build number. So now we have a way to set the version number. It means that every time that you commit something, you will have a different version for your artifact. And now it's time to package this into a jar file or a WAR file. To do this, the first thing that you need to do is for all projects, apply the versioning.gradle file. This is the file that we've seen here. Versioning Gradle is this file. So what I'm saying is, okay, for all the projects that in the project, overwrite the version, which in theory is 1.0 snapshot, to 1.0 the build number. Then, if you're doing a WAR, maybe you want to put in the manifest the version as well. So what you can do is WAR, since the project is a WAR, WAR is a special keyword. You say, okay, for the WAR, just when I'm building the WAR, just execute this code. And in this case, the code is creating a manifest entry, which is going to be implementation version, and it will be the project.version.toString. And this is very important. For this reason, I said that you need to override toString, because now project.version is not a string as originally it was, but it's the project version class. And then you can call griddle assemble, and that's all. Griddle will take your binaries and create an artifact, a WAR file, or a jar file with the name and the version that it has been calculated. We're almost done for the commit stage. Now you need to publish these artifacts to an artifact repository. Probably you're using Nexus or Artifactory. So you want to store something there. And to do it, you need to use another plugin, which is called Maven Publish plugin. You do apply plugin, Maven Publish. And remember that if you are using Maven, you know that when you store something in Nexus, you are storing your jar file, the source, and the Java doc. This plus the SHA and the key and the signing information, but the artifacts are these three ones. And this is not provided by default by Griddle, so you need to create it by yourself. And basically, you need to create a task called of type jar, which just says, I want to create a jar file with these contents. And the contents is source_sets.main.all_java. So you're saying, take source main Java, take all these Java files, and put it inside a jar. The same for Javadoc. The Javadoc you're just saying is, it's a type a jar, and depends on Javadoc. You're saying, when I execute Javadoc jar task, I'm going to run the Javadoc task automatically, create the Javadoc, and then put into a jar file the javadoc.destination_dir. Basically, is all the content of your Javadoc. And finally, what you want to do is, okay, I have the jar file with my application. I have my jar file with my sources. I have my jar file with my Javadoc. I want to upload it to somewhere. So what you do is using the publishing method, you do publish publications. This is a web application from components.web. What you're saying here is, okay, take the component web, which is a WAR file, and upload it, and also upload source jar and java.jar tasks. Notice that I'm using artifact, and source jar is the name of the task, and artifact java.jar is the name of the task that I've defined above, with qualifier, which means that put the slash sources and slash java.doc. And finally, you define in which repository you want to upload it. Using repositories, Maven, if it's a Maven repository, and you put the URL, and when you run griddle publish, it will take the WAR file, generate the sources jar file, generate the java.doc file, and upload this to your repo. This is something that, yeah, with Maven it's easier because it comes by default. But since Gradle is not Maven, and what you want to do is like integrating Gradle to a Maven repository, then you need to do this code. But yeah, at the end, it's you can even extract this into another Gradle file, and you can do an apply. And for all, you can share it with all your projects. And that's all for the commit stage. And then it starts a very important stage, which is called acceptance stage. That is where you run long tests where it takes a lot of time to execute, and you check not things from the technical point of view, but from the business point of view. So this stage basically it's, I have a WAR file in my artifact repository. So what I want to do is deploy this to an environment, maybe QA environment, maybe a stress environment, or the environment you have. Run the acceptance test, run the stress test, run the contract test, run more tests. This is depending on your policy. And finally is where you decide if you want to deploy it to production or not, after all this pipeline. Notice that the most important thing is test, because you need to be sure that everything matches the quality you expect. For acceptance tests, I really like this tool called Serenity BDD. Basically, Serenity BDD is an automatic acceptance test framework with a style that creates, it's really easy to create acceptance tests because it has support for JUnit, JBehave, or Cucumber. And the good thing about Serenity BDD is that it creates a really awesome reports. You get reports something like this, where you can see is which acceptance test has passed, which not, and even he knows which has been not implemented yet. So you get a real report of the current state of your project, because you know, look, I've created the 70% of my acceptance test, but there is still some acceptance tests that are not being implemented, and well, you can check the coverage as well. So yeah, I mean, the good thing about Serenity BDD is that it integrates with an already existing application like JBehave and Cucumber, and it gives you a really useful reports. For a stress test, maybe we have Gatling. I don't know if you know Gatling. Gatling basically is like JMeter, but instead of dealing with XML, it's a Scala ACA project. So it means that you can use a Scala for writing your stress test. So you are free of doing whatever you want in your stress tests instead of relying on XMLs. And it creates a really awesome report as well, where you can see the mean time of the response. Well, a lot of information about the stress. Also, if you're using microservices, probably you're interested in contract tests. I don't know if you know what is contract test. Anyone knows what is contract test? Yeah? Okay, yeah. Basically, contract test is that if you have one service that calls another service, and if you're using microservices, both services have different life cycles, it means that I'm talking with this, reaching some endpoints, and this can respond me some data, probably in JSON file. What's happening if this microservice evolves in fastly than this one? Then this one can change something from the return type. Then what's happened when this test wants to ask something to these other microservices, and this one returns something that this doesn't expect. Doesn't expect because this has evolved faster, and it means that maybe the developer has changed something without knowing that he's changing something that other microservices are expecting. So to detect this before going to production, there is contract tests. And I think that one of the most complete tool is packed unpacked JVM. And you can see here the schema. Basically, you have a consumer, and what you do is create a stub with what the consumer expects. So you run your tests against a stub. So you know that these tests are going to pass, and these steps generate a file with all the incoming and outgoing messages. This file then it's moved to the provider, which is the one who provides something, and you run this pack file against the service. So basically what it does is, okay, I'm going to send all the incoming messages that I know that the consumer has done in their test, and I'm going to see if you returns the same that I have stubbed. If it's okay, then it means that you have not break anything, so we can continue the development. If not, you're going to detect that something has changed. And this is what contract-driven tests or contract tests are about. And of course, we have talked about all the parts of the pipeline, and we have seen that I said, yeah, and then you can run Gradle compile, and then you do Gradle test, and then Gradle integration test, and then Gradle assemble, and then Gradle publish, and so on. But you need someone to orchestrate all these calls, because you don't want to do it in your machine or manually. And I may say that probably the de facto continuous integration tool is Jenkins. I know that some people are using Bamboo and maybe Travis and so on, but I think that this is the most used. And yeah, basically Jenkins has like over 1,000 Jenkins plugins. It integrates with over 100 DevOps tools. You can see that it covers all the pipeline stages from code and commit, build, scan, test, release, or deploy. We support GitHub, Maven, Gradle, Docker. You can see that you can even deploy to Amazon, VMware, Google Engine, OpenStack. I mean that I'm sure that you can do everything with Jenkins. It covers the from end to end of the continuous delivery pipeline. And probably what you are doing is something like this: that you create a new build job, you do an execute shell, and in this execute shell, you will do something like griddle, compile Java, and then in the post-build actions, you will add something like, okay, then run another project, which is called test, and in this test, you will create a new freestyle job project where you're going to do more shell calls like Riddle test, Riddle integration test. Well, probably most of you that are using Jenkins knows what I'm talking about. And finally, your project will have something like this. You will have, for all your service, you will have one build step, another one test step, another one deploy step. All of them, it will be different jobs, and you will link them as with upstream and downstream thing. And this is pretty bad in the microservices approach, because every service have its own life cycle. So it means that for each service, you will have that in this case, you will have for each microservice, you will have 3 Jenkins jobs. So if you have 30 microservices, it means that you will have 90 jobs there without exactly knowing what they are doing there. So yeah, probably what you people ask is, please no more jobs. Yeah, because at the end you have a Jenkins with 1,000 jobs and you don't know exactly what you're looking for or what to do. And for this reason, from CloudBees, we created a Jenkins pipeline as code approach, which basically is Jenkins configuration using implemented as a groovy DSL. And this means that you can, as in Gradle, you can put your groovy code inside your Jenkins file for deploying something. Basically, the features of pipeline plugin is that the configuration is in the source repository, because since it's a groovy file, it means that you don't need to go to your Jenkins and configure there, but it's the developer who is in charge of creating how they want to deploy its own system. It means less click and type, because usually you go to there and you do free job, add new step, add and add post build action and so on. It's quite tedious, and since you are doing with code, it's quite better. It covers from simple to complex scenarios. Survives Jenkins restarts and connection losses. If you're using your pipeline and in the middle the server goes down, when you start again Jenkins, it will start in the same place where it left. And this is something that you can do with freestyle projects. You can reuse the definitions, and this is pretty important, because since it's code and you have files, you can put these files into a repo and you can get it there. You will see that instead of, probably you've seen that it's quite not obvious how to deal with when you have multiple branches with Jenkins. It's quite annoying, and pipeline plugin really fixes this. It creates a new UI for seeing the pipeline. And it's really easy. You only need to create a new pipeline job, and you do that. You want to get the Jenkins file from an SCM. You define the SCM. You put here in the script path, which is the file that contains all the definitions, and you generate this job. And then when you push something to that repo, Jenkins will react and will read this file and execute your pipeline. Let's say this is an example. The first thing that you can put is, this is a Jenkins file, okay? You can put a stage and create, this stage is something that is for documentation purposes. You say the stage compile, and it said, okay, here starts the compile stage. Then you use the node. This is if you have a farm of Jenkins, you want to execute this code inside a node. So you define, okay, I'm going to execute this in a node. And basically what I'm going to do is check out SCM. It's like check the code from the SCM where the Jenkins file has been defined. Execute this shell script. You say you do sh and gradle clean compile Java. And if this happens, then stash the sources. Notice that I'm doing includes everything except build. So I'm putting all the sources into a stash. Stash is like a shared memory between all the masters and all the slaves of your Jenkins infrastructure. And this is done in this way because after you have done the checkout, you don't want you're going to start doing things, and you don't want that in the middle if someone commits something, you don't want to test something that has not passed all the steps. So it's a way to isolate the build. So when you do a stash, you are isolating all your source code from the external factors. And then you can create a new stage, which is called commit test. That is the commit test execution. Notice that I'm using parallel. This means that, okay, I want to execute this in parallel. And you said the first one is the unit test, and search a node. And when you have this node, check on a stash the source. So get the source code, do griddle test, include the jaco files, and finally archive the JUnit results. And then in parallel, you're going to run integration with a new node and using an stash and again using the griddle, -p, happy path, and so on. Notice that this is very important that you are using two nodes. And this means that, and it's in parallel, it means that Jenkins is going to take one executor, it will start execute this, and then it will take another executor, and it will execute the integration test. It means that if you have executors in different machines, they are going to be executed in a true parallel environment. Of course, you have seen here that I'm using sh, which is shell, and using griddle, clean, compile, Java, and I'm doing this again and again. What you can do is create a griddle.groovy file, which is a groovy file that has a method called assemble that basically calls another method that is called run assemble switches. And if you see the run method, it's like it composed a griddle command, and do the sh griddle command.toString. So what I'm doing is putting all the logic inside a groovy file. And then I need to put return this. This is very important. And then in my file, I can do def griddle load Jenkins/griddle.groovy, which is this file. And I can use node Linux, which means find me a node. It's labeled like Linux. Unattach the sources, and with environment variable source build number, put the build number of this. The build number here is the build number of the Jenkins, and do or call griddle.assemble. Notice that now instead of calling shell griddle blah 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 blah, what I'm doing is reusing the griddle.groovy library that I've created. And if you put this griddle.groovy in a shared space, then all your jobs can reuse that library, and you can call griddle.assemble instead of calling shell scripts. You can do more things like getting feedback from the user, something like deploy application to QA, and then it will appear a window, but you can say proceed or abort. You can even add in any stage concurrency. It means that if you have when you want to deploy something, you don't want to deploy things in parallel, because you could mess everything. So what you're going to do is, okay, if there are several jobs of the same project that are arriving at this stage, I only want to execute one, deploy to production, and then I will do the another one, and not both at the same time. You can echo, this is for logging purposes, and even you can use, for example, with credentials, which you said, okay, I've got my credentials section. I've defined here my, for example, my username and password of Git, and what I want to do is push something. So I can do with credentials. You put it here, your credential ID, which is the ID that you have defined in your global credential section, and then you can use it as an environment variable inside this block. So you can git push this thing. And even you can send emails, send HipChat messages by, this is something that you can check in the documentation. Of course, most of you, or hope that most of you can use Docker, and pipeline is ready for Docker. Basically, you can do is, you have a variable called Docker, and you can do Docker with registry. You set the registry there. Notice that there is a long number. This is the credentials for accessing this registry, and set git this repo. This means that you can get information from multiple SCMs, not for only the SCM where the Jenkins file is. And then you can do Docker build with this name, and then do new IPP, which is what returns the build. This is the variable that represents the container created, push, and they will put in the registry you have defined this Docker container. You can even, for example, use with run. This means that Jenkins is going to start the container, execute the content that is inside the block, but not inside the container. So for example, you can run functional tests against this container, and finally, it will stop the container. Or you can even do something like Docker image. You put the image you want to use. Then I'm sharing the Griddle artifact folder to not download it again and again. And then I said, execute Griddle compile Java. So what I'm doing here is I'm starting JDK 8 image. When it's started, I'm going to run Riddle compile Java inside that container. And the good news for you is that the workspace is shared automatically from the host and the container. So you can run your builds in a controlled way with the versions that you really need. I've said that UIs, this is the new UI for the pipeline. You can see that the stage thing is the one that you can see at the top, and then you can see all the builds and all the stages and all the time that takes every step. Also, you can, as I said, there is the multi-branch pipeline plugin, which is something from pipeline, that basically what you do is you define where is your Git repository, They include branches that you want to be aware. In this case, it's all of them. And then it creates only one job with all the branches. And when you create new branch, then it will appear here and will run the job automatically for you. Let's read down what we have seen. Notice that I've only talked about one thing, which is Griddle and Jenkins, but it's really important, the test part, the culture of your company. Keep in mind that if you have a crappy process and you automate it, what you get is a crappy automated process. So if you are not you're not delivering your software correct, continuous delivery is not going to fix it. So first, define a good delivery process and then automate it. Of course, follow the rules because there is a lot of books, but adapt to your needs. Sometimes you need to do something that it's not exactly what the book says, but it's okay. I think that you know better than anyone your business. So if you need to change something, do it. And yeah, in CloudBees we are doing a lot of efforts in Jenkins. I really like this quote about Deming, which says, "It's not necessary to change. Survival is not mandatory." So yeah, you can adapt continuous delivery or not, but yeah, it's up to you. And you can see my slides here. Thank you very much.